Hello, welcome to you in the fifth sem syllabus. It's a long time since we have met. Now, in this class, that is on Wednesday, we will discuss group theory. You will find it in the DAC 1 syllabus, new syllabus, because DACs are all in the new syllabus and the CC papers are of the old syllabus. Now, regarding the group theory, the book that comes in our mind first is Group Theory for Physicists by Joshi. Number two, Group Theory by Kingham. Now these two books are very good books, but a part of the syllabus will not be covered in both these two books. I will tell you later which book to follow for that continuous group or the lead group part. Now the first thing that comes in our mind is what is group theory? What is a group rather? We are all acquainted with the set. Yes. Set is a mathematical object that contains objects having some similarity. As for example, Ganges, Tista, Jalangi, Mahananda. What is common in them? They are all rivers of West Bengal. So they form a set. Some rivers of West Bengal are written in this bracket, curly bracket. This is what we call set, having similar property. The similar property here is they are rivers of the West Bengal. Now let us give me one example. This example I will follow throughout my lecture of these two. Now it is round, perhaps you are wondering what it is. Now I think you are going to guess that, well, it is the face of a clock, and this is only one hand of the clock. It may be second, it may be minute, it may be hour. Now how many numbers are there? Apparently it is 1 to 12, but you know there is one hidden number At the beginning it is not 12, it is 0. So I have numbers in this set: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a set. That is, we will not consider the numbers in between. Say it is midway between 12 and 1, we will call it 0.5. No, either it is 0 or 1 or 2 or 3 or 4, some discrete points. We may also talk about the set of integers from minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, up to infinity. The set of all the set of integers. Now we will say that some special sets are groups. Some special sets are groups. That is, these cells, these sets are restricted by some rules. We will just study what are those rules. These two groups are there, these two sets are there, and I am saying that these are the examples of set. Group. So we will see one by one what are those conditions and how they are verified using these two very special sets. Number one, to understand the number one procedure, we need to understand this operator. A very simple operator, plus you know its meaning from your nursery days. But in this case, we have a special significance. Some liberty is added to this symbol. Whatever I will do, it will be denoted by plus. It is no more addition, it is no more plus, but it denotes some binary operation. How it is? Say, I am considering a very special operation. I am considering in the set 1, 1 plus 3. I am defining it like this. Well, 1 is in the second position and 3 is in the fourth position, and we will add these two positions to get the new number. 2 plus 4 is 6, 1, 2, 3, 4, 5, 6. So it is 5. If you have a young brother or sister, he or she may object to this kind of addition, but I am correct. You can have your own rule. Say I am saying that I will add them manually. 1 plus 3 equals to 4. Okay, it is okay with it. But not always. Say I am adding 9 plus 10. It cannot be 19 because I do not have that number. Well, if you go back to the clock, this is your 9 position, this is your 10 position, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8. Now what is 19? You just count, this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now in the clock, what it reads? It reads 7. So it is 7. It is called modulo addition. It has a modulo 12. That is, the number cannot be greater than 12. Now, if I consider this modulo addition in my mind, then our rule is if A and B are any two elements of these sets, then A plus B equals to C will also be a member of the set. Plain argument. If A and B are two elements of the set, then our binary operation A plus B gives you C. I am no longer calling it addition. It may be whatever rule you use, you will get a number C. That C must be within the set. Our plain number addition is valid for this set too. Say I have 9 plus 10, it is 19. 19 is also a member of the set. So plain addition is also allowed in the if we use the integers, the set of all integers, then obviously this relation holds good. Now we will have our next relation. This relation is known as the associativity. Now what is that rule? A plus B plus C equals to A plus B plus C. It seems quite obvious, but not always. In some cases, you will see that this thing doesn't take place because this is not addition. This is, I told you, some binary operation, whatever may be. Now, if I go by my clock example, say A equals to 3, B equals to 2, and C equals to 8, then what is the value for A plus B? It means 5. What is the value for 5 plus 8? It means 1. 13 means 1. So, in this case, the value is 1. If I add this first, 2 plus 8 is 10, 10 plus 3, it gives you again 1. So you can see that associativity is guaranteed in this set. In this set also, it is actually a very simple case having all integers. So if you add in your natural way, A plus B will give you 5 and C gives you 8. So it is 5 plus 8 is 13. This is 3 and this is 2 plus 8 is 10. So it again gives you 13. So associative is obeyed. Now our third rule. Our third rule is there must be a number A prime such that actually we had the third rule. There exists a number E called the neutral number such that A plus E equals to E plus A equals to A. It is needless to say that is the choice of the number is 0. So if you have A equals to 5 then 5 plus 0 equals to 0 plus 5 equals to 5. So it is all going well. In this case also, 5 plus 0 is 0 plus 5 equals to 5. So this rule is easily understood in the case of group. And what about this relation? There exists for every number a in the set, there exists a number a prime such that a plus a prime equals to a prime plus a equals to e. So if you have a equals to 5 and you have the clock face, well, if you have this clock face and a equals to say 5, then you will have to make it e, and you know that e is 0. So how much value is a prime? This is 1, 2, 3, 4, 5, 6, 7. You will have to move 7 more um, digits. So 5 plus 7 is 0 in this case, and therefore a prime equals to 7. So our theorem is, if I have an element A, then there exists another element A prime such that A plus A prime equals to A prime plus A equals to E. E is 0 of course in this case, or 12, whatever you may like to say. And S2 is also in this case also, obviously, if you consider the natural number, then a plus a prime, if you have 5 for a, then a prime should be equal to minus 5. For any number say a of this set, the a prime will be minus a. And in this case, it is very interesting that if you say, well, a is 5, then a prime is minus a, and the value of minus a will be 7. There will be no negative numbers. So I think this is an introduction of what is group. I will give you some questions on, I think, Saturday, and you will have to answer it before Wednesday. Uh, the questions will come and you will have to answer it. Before concluding, let me say that in this lecture, it appears that these numbers are all discrete. Between 0 and 1, there are no numbers, 0 0.5, etc. So it appears that group theory deals with discrete numbers. Well, it is not so actually. We will see in the later part of our syllabus that we will consider the continuous groups where we will have gradual changes of values. All values between 0 to 12, those are acceptable. One more small point I want to give you some reason. That is, in this case, I told you that set theory is always linked with some symmetry. So what kind of symmetry this has? This type of symmetry is called rotational symmetry. That is, if you rotate by 360 degree, you will again return to any point. So it has some rotational symmetry, and in this case, you will have translational symmetry. This is the 0, and these are the points on the positive side, these are the points on the negative side. So if you hop 3 steps forward, you are getting here. You hop 3 steps backward, you again return to this point. So there is some translational symmetry. In this case, you are going 3 steps here, another person goes 3 steps here. So these 3 steps measures equal. So there is obviously some translational symmetry in what we said also. And I told you that we will have groups and symmetries are more somewhat linked to one another for the physicists. Well, thank you. This is, I think, enough for today because you know Zoom classes are not perpetual. So let us end the discussion today. We will again take up group theory on Wednesday.